In this lesson, we're going to be learning how to multiply matrices. Okay, so we've learned how to add, subtract, and multiply by a scalar, but this will be the first time we actually multiply matrices together. You're going to see it's kind of weird. It's a little bit on the weird side. So before we start the actual lesson, here are some warm-up questions. First one, how do you find the dimensions of a matrix? So you remember that I gave you the hint, or I gave you the tool that if you think of a delicious RC Cola, Royal Crown Cola, it helps you remember how to find the dimensions because RC is rows by columns. And that's exactly how you name the dimensions. We said it was an M by N matrix, remember? Yeah? Okay. And then the second one is we learned how to add and subtract matrices and how to multiply by a scalar. So the question here is, how do you think we're going to multiply matrices together? So give that a second. Just think about, ponder it for a second. If you're going to multiply two matrices, what makes sense? Well, most people would say it makes sense that you do it just like add and subtracting, that you would take corresponding elements and then just multiply them together, right? That makes sense. However, it's wrong. Okay, so if you think that's weird, well, that's because matrix multiplication is a little bit weird. So here we have a RC Cola advertisement, an old one, because our objective is being able to multiply matrices, and one of the first things that you have to do when you multiply matrices is find the dimensions, rows by columns. Also, whenever you go to multiply matrices together, you're going to see that it's a row times a column. And I don't know about you, but it looks to me like this lady in this picture here really likes to do some matrix multiplication. I can tell. It's right. It's written all over her face. So if you think matrix multiplication is a little bit weird, we have this guy to thank. That's Arthur Cayley. He's the one who kind of came up with this whole idea, this whole notion of a matrix, and did it about the 1850s. And he's one of the mathematicians, one of quite a few mathematicians who just kind of did math for a hobby, just for fun. Weird, huh? And like his actual job as being a lawyer. So because of the way matrix multiplication is defined, you can only multiply two matrices like A and B together if the number of columns in the first one matches the number of rows in the second one. And that's weird. And maybe me saying it in words doesn't make much sense to you, so let's look at it as an actual example of things. So here is my matrix A. I just made up some random numbers. Here's my matrix B. First thing you want to do is find the order of each of those matrices. So matrix A has got 3 rows and 2 columns, right? So it is a 3 by 2. Okay. B, it's a square matrix. It's got 2 rows, 2 columns. It's a 2 by 2. Okay. So what I said, in order to get to multiply these two matrices together, the number of columns in the first one, that's that green number 2, has to match up the number of rows in the second one. That's the red number 2 over there on the right. So the easiest way to do is just you write them down, a 3 by 2 and a 2 by 2, and the numbers that are right in the middle, they have to match. If they match, you can find the product of those two matrices. And something that's weird here is that unlike matrix addition and matrix subtraction, you don't have to have the same size matrix in order to get to multiply them. Okay? So the second part of this is your answer is also given to you by the dimensions of the original ones. You take the number that's on the number of rows from the first one, and it's the number of columns from the second one. So here's what your answer will look like, and just watch this little animation here. The order is going to be a 3 by 2. That 3 came from the first one, and the 2 came from the second one, right? So that's the very first thing that you always do whenever you go to multiply two matrices, is you got to see if you can do it, and what size is it going to be whenever you get done. If you're wondering about all those weird little symbols inside there, just made up symbols. I just didn't want you to worry about what the actual numbers are. Just want you to focus on what the order of the product is supposed to be. Okay, So think of this as kind of getting rid of the middleman. So if matrix A has order m by n, and matrix B has order n by p, then the answer, the product, is going to be m times p. So you make the middles match, and if they match, you get rid of those, and you take the first one times the last one, an m times a p, okay? So this is the first thing that you have to do before you actually even multiply the two matrices, is you got to see what size it's going to be, and if you can actually do it. Okay, so let's look at a couple of examples of this. We're not multiplying here. We're just seeing if we're allowed to. And if we are, what size is the product going to be? What is its order? Okay. So on the first one, I have a 5 by 2, and I'm going to multiply it by a 2 by 2. So remember, what I do is I check to see if the middle numbers match. Check, they do. And then I'm going to get rid of those and say that my answer AB is going to be a 5, that's the first number, by 2. That's the second number. It's going to be a 5 by 2. Okay? All right. Number 2, do the same thing here. I've got a 3 by 2, and I'm multiplying it by another 3 by 2. Right? It's the same size matrix. However, whenever I go to check the middle guys, they don't match up. They do not match up, so you can't do this problem. That's a big fat nope. Can't do the multiplication on that one, which might be a little bit on the strange side.